Okay, so Gwen mentioned notifications, and I just thought I would try to make it concrete. I'm not the most super active person in terms of like code reviews and PRs and things like that compared to others, but my GitHub notifications is right there. Like there's 10,000, it stops counting at some point. At some point everybody gets swamped. So as you're going through this process, know that everyone on the other side of the computer is actually a human too, and it's not like they're ignoring you. It's just complicated. Okay, so let's see here. With only one screen, this is going to be slightly complicated to go through, but hopefully we're able to bounce between a little bit of slideware and some actual demos, and maybe some of you will be able to follow along. Honestly, I expect a bunch of failure, and this is good. We can try to work through some of the things. It'll give you, if nothing else, a starting point, some orientation to see. This is a very large, complex project, and if you're thinking about building a very large, complex project, you gotta be prepared for some struggle. And there will be multiple aspects of this, and the first one is you need to think about your development environment. So I'm here today to talk about local development, which means like on this thing, you're on your laptop probably. And realistically, laptops today are kind of barely strong enough to build Kubernetes. So you want to have as much RAM as possible. One of the most frequent things I run into is if I'm building things broadly, is I have link time failures because I've run out of memory and all this stuff's building in parallel and it just starts getting killed by the OS. So lots of RAM. Also lots of CPU. Depending on how we progress here, we're going to make the room warm as all of our laptops try to start building this. And then also disk space. As I was prepping, making sure everything was set up to try and do some demos today, I ran myself out of disk space in my test VM. And you might think, well, I'm in Windows or I'm on a Mac, I'm going to just make a little Linux VM to play around with this Kubernetes thing. I'll give it a 10 gig hard drive. You will be out of disk extremely quickly. I just went and deleted like 50 gigs worth of stuff to make some room so that I could build again. So it's like multiple tens of gigabytes that you need to make sure you have around. And then depending on whether you're familiar with Docker or not, in Linux, your varlib Docker regularly just explodes full of images and volumes and things you weren't even thinking about. And quite often, you'll just need to go in there and clean that out to free up some space. Another maybe opinionated, hopefully not too controversial thing that I'll throw out here is I really suggest starting with Linux. I've got a Mac here. It's possible to do some of these things on a Mac. It's possible to do these things in Windows with the Linux subsystem. But a lot of it really is presupposing or expecting that you're running Linux. And most people probably are. Even if you look around and see a bunch of Windows or Mac machines, they're probably within that doing things in Linux. Then you also have to think about, well, I'm running Linux in a VM, so I have contention between the memory allocated to the OS and to the VM and the disk space and all of those things. So you're going to need to play at sysadmin and make sure you have lots of resources allocated to your dev environment, and it will be constrained on your laptop. Using Linux is one way of just ensuring that the basic standard documentation is right. And I say start there because it's the most well-documented path. If you start there, you're going to have the least friction. Sure, if you're passionate about a different OS, graduate onto that. Cool, awesome. Improve the docs there, submit PRs. But don't make your life extra hard up front because there's a whole bunch of other things that you're going to need to struggle your way through as well. The very first one actually came up in the back of the room a few minutes ago as somebody was trying to do this on their own. They noticed there was a makefile, hit make, ran make, and it failed. And the reason it was failing is the location. I think most of us day to day get used to checking something out of GitHub and building it. I, in my home directory, have a directory I call source. On some of my computers, because I used to do Linux work, and the Linux kernel used to assume that you were in user source Linux, I check things out to user source Linux or maybe my home source. Kubernetes wants to and will fail to build if you are not in the right place within your Go path. So whatever your Go path is set to, you have a source subdirectory, that's normal. Beyond that is things that you've done a go get on. And Kubernetes wants to have been checked out into k8s.io/Kubernetes. And you will have build failures. It'll just be a whole spew of things saying could not find package something or other. And that's a pretty sure sign that you've run into this. And for a lot of people, I think this is different than how they may normally do their development. And then another gotcha there is if you're doing development, you're probably, as Gwen had just talked about, you're doing it on a fork, which means you've forked the KK repo into your own, you've cloned that somewhere onto your disk. You probably didn't choose to clone it into the same place that go-get automatically clones read-only stuff. So you may need to deal with your Git remotes and make sure that things are aligned for this pull request workflow that Gwen talked about on GitHub. And then finally, you want to start thinking about what you might use for a test cluster. Because Kubernetes is a cluster system, if you're going to do meaningful testing, you need a cluster. So I'll get into that in a little more detail, but maybe you can mentally be thinking about what do I have for resources. Your company may have an affinity to AWS or GCP, or I work for VMware, maybe you use our stuff, or I have a pile of little Intel NUCs on my desk with a switch and have my own little physical bare metal cluster. There's a bunch of options. So building, I kind of started to get into this. It's Golang, but we have make files. This is weird, probably, compared to other Go things. And not only are there make files, there's a bunch of shell scripts. So if you've got your Kubernetes directory, you cd into it, you might do a ./build/run.sh make, which doesn't seem like a normal thing if you're used to Unix make. It's not a normal thing if you're used to Go. So there's kind of a mix of paradigms here. With make, there's a bunch of different targets. There's things like make quick release or make what, and you can specify a particular thing. So one of the things I realized, I don't know that we've actually presented sort of an architectural diagram of what a Kubernetes cluster looks like. So you have multiple components. You have sort of a control plane with things like the API server. You have clients that run kubectl. You've got worker nodes that are running kubelet. So all of these things are talking to each other. Those are individual binaries that are running on machines or virtual machines somewhere. And you can build them individually. And this can be a handy thing, and I'll go into it a little bit later just to sort of demo what a build looks like. But again, as a newcomer, you're like, what? This just doesn't make sense. And I'm relatively new to Kubernetes, don't blame me. It's like, we've got a bunch of legacy stuff, and we're working on making it better and more coherent. And Gwen especially has done a lot of work this last year making sure that we at least have this better documented. So as you come to it, you can read some things that are like sort of script playbooks to work your way through. And then finally, all of this happens inside a container. So just like I sort of argued for starting out with Linux to keep things simpler, the core software build infrastructure people at some point in the past decided like it's too difficult to manage all of the possible dependency differences across everybody's build machine. So we're just going to make a build container, and part of the first build step is to download that container and run it just to give a level environment for building. All right, next up, testing. And actually, I'm gonna pause here, and I'm going to try to do a quick demonstration of that before I go test. All right, so first of all, I tried to make sure this was relatively readable. Can people see that okay? Okay. So my Go path happens to be home tpepper go, and I'm down in home tpepper go source, k8s.io Kubernetes, like I said, where it's expected. And then I've gone into the subdirectory package kubectl. If I'm at the top, I've got a makefile. And I can do something like make what equals command kubectl. And it's going to go off and try and build that for me. And this is Go. It's usually relatively quick, but there's some semi-complex things. But these smaller build things build relatively quickly. And you can have on individual pieces, parts, you can have a pretty quick development, deploy, test sort of workflow. And I guess maybe that's another way of saying don't Don't just run make or try to build the whole thing. I did a make quick release on my laptop, and it took 10 minutes. The last time I did like a full build, because it does cross building of all the architectures, it took like 45 minutes, and I thought my laptop was going to melt. And there's generally no reason, unless you're like building a Kubernetes distribution, to build the whole thing. So I was hoping that would be done by now. Let's go back to start talking about testing here for a moment. So assuming you're getting to where you can make code modifications and test things, or make code modifications and build things, the next step is to test them, right? So like most big projects, I think you'll see a couple of layers of tests are available in Kubernetes. And right now we have 4. Until just recently, this was 3. We added the bottom one there. So you've got unit tests, and these are your normal native Golang tests, if you're familiar with Go. The next level up is integration tests. So Go unit tests, generally speaking, you just run Go test on the command line. They're isolated right there. They run. They give output and feedback. But an integration test, if what you're building in Go has some external dependency. So like Kubernetes depends on etcd. If you wanted to test code that interacts between those two, you actually need an etcd running. So these integration tests enable those types of somewhat constrained, but still cross-package or cross-component interaction testing. The next level up then is going from some sort of test code and an external component to the whole of a cluster. So what we call end-to-end, or you'll regularly see these abbreviated E2E. The E2E tests are doing the overall interactions and behaviors of a full cluster. And that either means that you've brought a cluster ahead of testing, or you use some of the test infrastructure to spin up sort of an ephemeral minimal cluster to run some tests against. And then the 4th level, conformance testing, these are a subset of the end-to-end tests, and this is something new that the governance of Kubernetes has decided is necessary. There's like 80 some odd vendors and distributors of Kubernetes now. And as a project, we need to make sure that we have some coherency. When somebody says this is Kubernetes, that it means something. Any of those 80 vendors could potentially have patched something in an incompatible way, and that would lead to really bad outcomes for users if they don't understand what's that Kubernetes versus this Kubernetes. We just want one Kubernetes. So the conformance tests are end-to-end ones that the architecture SIG has said, these are really fundamental APIs, things that are core to interoperability of the well-known features. And it's a growing set, but it's still a subset. So let's just see. My build better have, yes, my build finished. So if you're doing a normal Go build, you might expect to find your binaries in a certain place, and they're not going to be there with Kubernetes. These make commands are sending outputs to the output directory. Local bin Linux AMD 64, because that's the platform I'm on. I was building kubectl, and if I do a long listing of that, we should see right now. I proved I can build stuff, yay. Not particularly impressive, right? But that's basically what it looks like. So if I wanted to run a test, a unit test, so something again related to kubectl, and there's a couple of talks I think during the conference that are sort of orientations to the code base. The code base is a big rambling code base, but for something like kubectl, there's 2 directories that you might look at. There's the command kubectl directory and the package kubectl directory. And if I look at those, the command directory, it doesn't have any unit tests. This is stuff related, just simple front-end. Package kubectl, though, has all of the actual stuff, and you see the normal Go test files. So if I go in there and go into kubectl package, I can go test ... like a normal Go thing. And again, this is Go. It runs pretty quickly. And there it is, unit test. So you have, if you're used to Go and doing that rapid iterative development, you have that same ability for unit tests. Oh, and I admit, I'm sorry. Did you all catch the short link that was on the prior screen, this one? I'd encourage you to go to this right now, actually. So hopefully that's really easy. bit.ly Kates-NCW new contributor workshop-testing. And this is a page that we got added into the contributor guide. I think we did this about a year ago, just to give an overview of these testing things. And from that, so this is the page that you'll land on after it resolves the short link. You've got a little bit more text about each of the types of tests: unit, integration, end-to-end, and conformance. And then there's also a number of links within here. This testing guide link is the first one I'd encourage you to look at. The Go tests are easy, right? You just cd in a directory that's got some underscore test and run Go test. But the other ones get more complicated. Like, how do I have to install etcd or some other component, and how do I do all of that? So the first link there jumps off to this testing guide that goes into a bunch more detail on how to run more detailed unit tests, and also how to start running the integration tests. So for example, I'd mentioned etcd. If you wanted to install etcd, we actually have a subdirectory called hack, and under that there's all these little scripts that are helpful. So hack install etcd.sh will install a minimal etcd that's sufficient for testing and is version matched against the code that you have checked out, all of that sort of stuff. So let's actually try and do that. I've already run this just to be a little faster. But feel free to try and run this and install it. It goes fairly quickly aside from the download portion. And basically what it wants to be able to see is that if you do a which etcd, that you have something. So I happen to have installed one in my personal bin directory. So there's an etcd in the path that's available to the test. Then the most simplest, broadest thing would be to make integration test. Oh, and you have to be in the top level directory where the makefile is. So you do that, it's going to do a little bit of validation of prerequisites. If you don't have etcd, it will come up and say, hey, you don't have etcd. For me, if I scroll up here, you can see one of the first things it looked for is etcd in your path? And it found it, it started up etcd, and it's headed off into running some tests. I think when I last ran this, it took like a half hour to run a bunch of these tests, and there were a variety of failures and things because I hadn't really set up all of it. But you can at least get started. From that link there, you can jump down into this documentation, and it's got a bunch of sets of commands. These are all set up for you to copy and paste and actually try and run. Some of them will take a while. You may have some system dependencies that you have to install. So then the next one is end-to-end tests. And again, this document, from the table of contents, you can jump to end-to-end. You'll see that those have gotten so complicated, we've moved them off to a separate document. So we go over to that one. And this is in our developer guide. And again, this document has a ton of information and a ton of ready to copy and paste code for doing all types of testing. But the one that I really want to highlight here is where it says local clusters. As you start out, I wonder if maybe we should reorganize this file, but as you start out, this is the place where you want to start, buried down in the hierarchy of the table of contents. So if you jump down to that link, it says, hey, it can be much faster to iterate on a local cluster instead of a cloud-based one. Doing things on your laptop is convenient, right? Yeah, so again, in this hack directory, we have a command that is local cluster up. I'm just going to kill that test. So it needs to run as root because some of the stuff in running a control plane is privileged. But you run the simple command, and it's going to try to set up a cluster for me for test purposes. Now, I'm running a Mac with Mac OS. I've got my Linux VM. This is going to do some extra stuff, creating some containers and spinning up some different things. So it's very easy to start running low on resources again here. And this is where you'll start realizing what the bounds of that are. It used to be that people recommend that you dedicate at least 4 gigs of RAM to Docker, and I suspect it might be a bit more than that now. So if you've got a lower end laptop, you might run into trouble here and might need to have a desktop machine with more RAM. So this command, hack local cluster up, feel free to try it. It runs relatively quickly, but it's going to go and run the things that it needs, or build the things that it needs to set up the cluster. Because we're talking about dev test, right? You don't want to just download arbitrary binaries from the web or have pre-built ones. It needs to make sure that it's running a cluster right now from the code that I have checked out. And I've checked out v1.13.0 right now. So it's building me this week's Kubernetes. So it's going to take some time. I think it takes a few minutes on my laptop for it to come up. And I tried to run this all to have it pre-cached and warm and ready. And it's still, you can see that it's slow. Once it gets things built, there's a few things that it does need to download in terms of commonizing the build requirements. And like I'd mentioned, some of the things are in a container. So it's downloading CFSSL, which is a tool for managing SSL certificates. It's going to actually build me a real cluster. It's going to generate SSL certificates, because nobody checks certificates into GitHub anymore, right? Like, that's bad. So it's going to actually generate new certificates for me, make a real cluster that's secure. The control plane is talking over SSL. It's got to download the tools for that, and we're cratering the internet probably in here, all downloading things. So once it gets up and running, the next thing that you need is a tool called kubetest. And what kubetest is going to do is manage all of the test cases versus this machine that you've configured here. And it needs a kube config. Actually, the slides for this will be shared afterwards, and I've tried to populate them with a bunch of helpful links. So I've gone through unit testing of just the basics, and we did sort of the simple integration showing make test integration. For the end-to-end tests, if you run the local up cluster, you set your config based on what that did, then you can use kubetest to run a specific command. And in the slides, I've got speaker notes for you that have links to all of these docs that describe each of them in detail, so you can try to follow along more on your own. OK, so thinking about this being an actual cluster, whether it's kubetest or if you wanted to use kubectl to talk to this cluster that's been spun up, you need a kube config. So, it's running. So if I scroll up here, there are some more things that scrolled by, but eventually it comes up and says, hey, your local Kubernetes cluster is running. Press Control-C to shut it down. It gives you some hints on where the logs are for the things that are running, and it tells you where your kube config is. So I'm just going to copy that. And I need to leave this terminal running so that my cluster is running. But I can export that kube config. And then I can do a couple things. I had just built that kubectl, right? So I could run that one that I just built. I mean, it's runnable. I could say kubectl get nodes. And there's my one node cluster that was spun up for me. And that's running the kubectl that I just built. You know that because I gave it an explicit path, right? But we could actually force and prove, and this is a pattern that I like to encourage people to do as they start out. If I'm not sure about my build test environment, well, let's just figure out if we're really doing it. I'm going to come in here and say, print line hello new contributor workshop. And throw in maybe a few new lines there to make it visible. I'm going to make what equals command cube. Oh, I did the wrong one. It helps if I do kubectl when I mean to do kubectl. Yes. Font print line. Hello. And CW. All right, then make what equals command cube cuddle. Yep, thank you. So that'll take just a few moments to build. It'll be in my output directory, and if I run this command again, instead of just seeing my one node cluster, I should see my little hello world, right? And then we get a quick little validation that I successfully built something, I've successfully started up a cluster, I've successfully made them talk to each other. That may take a second. While that's going, let's go back over to talking about the tests. So, which window am I in? Oh, well, it finished. Okay, so I made it. I run that same command again. Hello, it worked. I'm a developer. I can do something. So I encourage you to start simple like this. Because even though I've done it here in like 5 minutes, your first time, it might take you an hour or two as you figure out certain build dependencies or things in your environment that aren't there. If you're on a brand new Linux machine and it doesn't have any toolchainy related stuff, all of that stuff is going to need downloaded and installed. If you're trying to replicate this on a Mac, you might need to install Xcode at this point for the first time, and this stuff all takes time. So the end-to-end test, one of the next segments here is going to be talking about a thing called test grid, and it runs a bunch of these end-to-end tests. And within the test grid output on any given test results or a page, there's actually a little bit of stuff that you could copy and paste that's the exact details of the test that was run. So if you've been assigned to work on a test failure, you can actually use that to feed it into this command line as your guidance of saying, okay, this test was failing. I think I've written some code or I want to try and reproduce it. I'm going to run that as my command line. But right here, I've just got I've copy pasted the one from the documentation, and it's running a set of tests on, can't copy paste. It's running a set of secrets related tests. So I'm running kubetest. I'm saying provider local. You could also do this with a cloud provider. I'm telling it, because I have a single node cluster, don't try to start up a crazy amount of pods. And then focus the Ginkgo testing on this secrets bucket of tests. So if I run that, what failed? Of course. Local. Oh, yes, I didn't completely follow the instructions. What I should have been copy pasting, I think, had something else. Where are we? I have my cluster up. I did my path to my kube config. Why did it fail? Something went wrong. Encountered one error. E2E. So this is all just information. Oh no, I know what it. Yeah. Okay. So I do have a version mismatch. Every time I do this, and I validated it this morning. Okay. So I think what I did not do when I was resetting this up, I hadn't rebuilt kubetest, which is earlier in the instructions. It's very common to have version mismatches in your in your Go config especially, if a particular bug is found in the Go compiler such that it's generating code that has a problem, the project may have moved Go along. And I started doing this earlier, and I had the latest head. So right now, 1.14 development is underway, and it's like the first week of development, all sorts of crazy stuff's going in. And I hit a later failure because the tree was just unstable. So I backed up to v1.13, but I think some of the dependency things had changed in there. But it's actually easy to just go get this stuff, and go get will update that, and then things should match. This is YAML or JSON practically. It's not the most readable. I feel like most of the error messages are actually fairly human readable. So like on an integration test, if you don't have etcd, it will say, you don't have etcd. And it will actually give you a copy pastable command where you can just run this and you will now have an etcd. Still not happy. Dirty. Oh, the other thing, it's complaining that I'm dirty. I modified a file. No, not happy with that either. Well, rather than trying to debug it, since we're running short on time, I'm going to continue on to talk about briefly the conformance tests. And this one, I'm wondering if I actually forgot to copy paste something. So there's a couple other things in the conformance tests that you need to get set up. And again, from this test documentation, if you go in, there's conformance test documentation. There's kind of the high-level overview of what's what, and then you get into a set of copy-pastable commands. So the go get that I'd just done, this make command to set up some basic prerequisites for it itself. Again, you specify where your kube config is. One slight difference here is because these are all just end-to-end tests, you need to specify the conformance test variable in your environment. Say yes, and that informs kube tests that you're actually doing the conformance-related subset of things.
So it's not enough to tell Ginkgo that you are doing conformance?
Correct.
You need variable related. And what does it test exactly?
I don't know.
Conformant to what?
So I don't know what the variable specifically does, but conformance is validating that your output matches the expected for the tests. And there's a whole repository, there's actually a whole working group now under SIG testing that's working on broadening and expanding conformance, what it means. One of the big questions in the community is, what is conformance? What should it mean? So some of that's an open question. Obviously, some things like APIs run in a predictable way, give the same types of output. All of those types of things are clearly within. But even at that, we don't quite know in detail what our test coverage is for the API set. So there's some work to measure that, and some of the numbers have been relatively meager. So is a new contributor something you may find as you're running into a problem and it backs up to a difference between your cluster and some other cluster. Think about writing an end-to-end test that better describes that situation and talk to the community about maybe that should be something added to the conformance suite, because these are things we need to improve on. So I already got my kube config exported. Going to just copy paste that. And yeah, I guess in the whole suite, I think the last time I ran this, it took many hours maybe. But oops, if I copy paste that correctly. Okay, so it's off and running, testing things. Not particularly human readable, but there you go. Copy pasting these basic things can get you running conformance. There's a whole bunch more detail about conformance out there, and again, it's a conversation about what conformance could and should be. The final thing I wanted to touch briefly on was a thing called Minikube. So this set of testing that I did was running a simple, spontaneously created thing, but Minikube is a project that will run a cluster specifically in a VM. So what I had running there was a set of clusters not well contained within my development environment. Minikube will be a standalone VM, and it can use multiple different types of backends as well for the virtualizer, and it can be a potential way to have a simple cluster that you run. And then if you're really adventurous, one other option to get a simple cluster running, if you're doing just client-side stuff and you need a server against which to talk to and you're on Mac or Windows, the newer Docker, one of the things that you can do is go into Preferences, and there's a Kubernetes tab if you're on the Edge repo. And you can say, run a Kubernetes cluster for me whenever Docker is running on the system. And that could be a handy, simple cluster endpoint to have. Again, this is running in a VM on your machine. Stealing resources from things needs resources dedicated, but it may be an option for it's worth mentioning for local testability. And with that, I'm going to hand it back to Gwen. Hopefully that wasn't too much information. That one short link is your jumping off point to the 4 types of tests, all of the details on how to run some of those. Good luck.